small problem. So far, I've only talked to you about a golf ball hitting football. They're both neutral. Are quantum mechanical or atomic scales neutral? Are the particles neutral? No, they are not neutral. They have charges. So then we have to define new impact parameters depending on what kind of particle it is. So we can redefine our cross sections or scatterings as either, should I make this bigger? There we go. As neutral scattering or attractive scattering or repulsive scatterings. So if you ever hear these words, mostly textbooks write this as just scattering. And they write this as capture scattering, capture cross-section. And they don't call this anything, but I'm going to call it repulsive cross-section. So one of the things you may find, textbooks don't define this properly. And that is a source of a lot of confusion. For you, I will tell you to think about it this way. If you have a neutral scattering, the only impact that can happen is in between this tunnel. And your sigma will be pi r plus rh squared. Your scattering, your cross-section. Good? When you have an attractive scattering, this will look like that. So this was our original B. Oh, and then this is usually called B, right? But this is now, attractive scattering will always be between particles that have like charges or unlike charges. Unlike. So between a plus and a minus. So if there's a plus and there is a minus, we want to capture them, right? So can everybody just watch for a second? The impact parameter for attractive scattering will be bigger. Got it? You'll be able to attract it from further away. Okay? What happens if it's even further out than what you were thinking? It will still attract it, but then this happens. It's still scattered. So for a capture cross-section, your impact parameter will be larger. Good? Now what about repulsive? What would that look like? Yes.
For the capture cross-section, even if the two particles don't make contact, it's still considered scattering if it affects it.
Yeah, because it is doing something to it, right? It's still scattering it from its original path. And for the repulsive cross-section, will the particles be like charges or unlike charges? Like charges. Like charges. They don't like each other, right? The pluses and the minuses.